All right, so this is meant to be a reminder of the law of signs and go into what we call the ambiguous law of signs. So the law of signs is written at the top here, which you should be familiar with if we have some sort of triangle where we label the opposite side. Oops, sorry. Has a lowercase letter associated to it, right? So we have our angles as capital letters, and we have our side lengths as lowercase letters. So if we were given this information on the bottom left, that we have an angle A, which is 28 degrees, a side A that is 60, and a side B that is 100. So we've worked through this before, and we decided that the essential piece of using the law of signs is to be able to come up with at least one ratio. Okay, and so this is the case. Sometimes we were given two angles and we could find the other one to get our ratio. But on this case, we are given a full ratio. So if we were to go through the process of solving this, we know this ratio. The other thing that we know is that we have a side length of 100. And so it's just kind of natural for us to start out with this right here. So I'm going to cross multiply and use my inverse sign. So what I mean by that is I'm going to be typing in 100 times the sine of 28 is equal to 60 times the sine of angle B, and then I'm going to divide by the 60. Okay, so 100 sine 28 parentheses divided by 60, and I'm coming up with 0.78245 is equal to the sine of B, which is a good thing because we know sine goes from -1 to +1, so this means this triangle is possible. I'm going to use my arc sine or inverse sine of that decimal. I'm coming up with about 51.5 degrees. Okay? Now that we know that, the next thing we can figure out is this third angle because there's 180 degrees in a triangle, and so we could subtract our 28 and our 51.5, which leaves us with 100.5. Okay, and so now I'm going to go ahead and come up using these two ratios right here, much like I did before, but instead of it knowing the 100, it's going to be a little bit different. Okay. That's what I did to find that angle. So let's see here. So I'm going to take 60 times the sine of 100.5 is equal to, well, angle side C over the sine of 28. So I'm actually going to divide by the sine of 28. And I won't need to use any arc sines. So 60 sine 100.5 in parentheses divided by the sine of 28. And I'm coming up with 125.66, so 125.7. So we're deciding to round to the nearest 10. And it seems like this would just be like, ta-da, done, yes, awesome. Okay, unfortunately, that's not necessarily the way that this goes. Sorry to tell you. The reason it doesn't quite go that nicely is because if you think about our unit circle, even as much as you don't want to, okay, here's 0 degrees, here's 180 degrees. Now there are a whole bunch of places where you have the sine value more than once. So it's possible that we're talking about a triangle right here at 51 degrees. However, it's totally possible that we're really talking about a whole different triangle that has an angle that's 180 minus that. It's complement. It's at the same height. So sine was our y value. It's at the same height right here, right? Same height. So 180 minus 51.5 is actually 128.5. So what happens here is I have to completely redo this because I could have a whole different sign. So this is like my acute possibility, and then I have this obtuse possibility. Okay, so that is the real reason as to why in geometry they tell you that you can't really ever do a triangle with two side lengths and one angle. Um, and the reason is that other angle might be obtuse or it might be acute. And the only way that that ever worked, if you're given two side lengths and one angle, is if the angle was 90 degrees, because we know there cannot be two angles that are 90 or more. Okay, so the only way that ever worked was with right triangles, because there was no other option. So let's talk about this other option. So what we were given to begin with, that was concrete. Let's write that part down. We had the sine of 28, and we had a 60, and we had a 100. And we had to figure out these other options, right? So now, instead of being 51.5, the obtuse triangle would be the same as 128.5 because it is supplementary to the other angle. They have the same height. From here, we go ahead and figure out what the other one would be. Now, if this other one says, okay, hold on, we came up with this obtuse angle and there's just not enough left, right? Like if it was that right angle, there's not enough degrees left in my triangle to even mess with this. Then we just have to say, oh, okay. If I took 180 minus 28 minus 128.5, I'm coming up with 23.5 degrees as my other angle. Quite a bit different. So now if you look at this, now that angle C is my smallest. So it probably, instead of my largest, and now it shouldn't have the largest side length, right? So we're going to use, I'm always going to go back and use this original ratio that we were given so that there's no errors in that portion, okay? And we're going to do this like we did before. So I'm going to take 60 times the sine of 23.5 divided by the sine of 28. And I came up with, basically it rounds up to be a 51. 50.96. So 51. So what happens here is, given that information, we really have two different possibilities. And that's why this is called the ambiguous law of signs. Okay? Is there a trick to knowing when this happens? There might be. It just isn't worth it necessarily. So if you were ever given only one angle, and that angle is acute, we have to always allow ourselves to explore the possibilities on that first angle. Using with that first angle you find as a possibility that it could be acute or it could be obtuse. So we have to allow both possibilities. I want you guys to try these and go from there. Maybe.